fundamental question that we can ask as a scientist, besides why is there anything rather than nothing, is how does consciousness come about? We do what's called, we reverse engineer the brain. That means we try to take it apart into its individual components. Of course, ultimately the components are elementary particles, but we take it apart at the level that we think is relevant to understand memory, perception, intelligence, consciousness. That's nerve cells. Neurons are the atoms of perception. Neurons and the interconnection, that we believe, or the field in general believes, is a relevant level to understand how we think and how we remember things and how we act.
The main challenges faced in reverse engineering the brain are replicating the complexity and creating proficient technology. Joël Froelich from Psychology Today says, unlike simple phenomena like the swinging of a pendulum, emergent properties such as intelligence and consciousness cannot be understood by merely studying simple parts of a system. In terms of technology needed to achieve this task, the algorithms used in today's neural networks were developed in the 1980s and aren't nearly useful enough. Classical supercomputers which attempt to model the brain use millions of watts of power as compared to 20 watts for the brain.
Neuroscience is meshing with computer science to create more organic processors, including ones that aggregate a series of impulses similar to how a neuron fires. As a result, these processors will use significantly less power. These processors will aid in determining the fundamental systems that run the brain's sensory detection systems, revealing critical components of the brain. Coupled with more advanced sensors which can measure the firing of thousands of neurons at once, scientists can discover connections between sections of the brain.
The Center for Bioengineering has many unique capabilities, one of which is actually developing chronic implantable neural interface devices and other biomedical devices that allows us access to the human nervous system in ways that weren't before possible. And so it allows us to actually both get an understanding of the brain and the other parts of the nervous system, the peripheral nervous system, the eye, the ears, all the sensory organs we have in a way that you can't currently do. So it allows us both to get this understanding as well as reverse the course of diseases that affect all the human nervous system.
Listen Cooper suffered a car accident in 2004, has been paralyzed from the chest down. But now with Frontier Brain Implant, he can play his favorite video game with a computer-run keyboard emulator.
While scientists and engineers continue to make technical developments in replicating the human brain, philosophers ask important questions pertaining to the nature of the brain itself. What is the interaction between brain and mind? How can the two interact if they are fundamentally different things? Where does the mind reside? Can the human conscious be replicated? What do we define as the human conscious? One specific question philosophers can ponder is, if a reversed engineered brain understands the science and specifics behind color, can we say it is experiencing color like humans do?
Contemporary Australian philosopher Frank Jackson presents us with the thought experiment of Mary, a woman who has spent her entire life in a black and white room, learning everything via a black and white television. While locked in this room, Mary becomes a neurophysicist specializing in the science of color. She learns everything there is to know about light, optics, the physics of color, and how it affects our sensory organs, but she has never seen it for herself. So here's the question. When Mary finally walks out of the room and sees color for the first time, has Mary learned something new? Jackson devised this thought experiment as an argument against reductive physicalism. Because, Jackson says, the qualitative experience of seeing a color, say red, isn't the same as knowing facts about red.
Advanced electrophysiological tools. So this is basically wiretapping the brain. So driven by silicon micromachining and nanofabrication technologies, we can now put hundreds to thousands of electrodes in the brain, literally wiretapping the activity of cells. And then there's also been a renaissance in imaging, so we can insert genes for fluorescent proteins that make neurons glow when they're active. And this lets us literally watch a thought in a living brain. So right now you're watching over on the right a rat experiencing a three-dimensional object, and you can see the cells lighting up in real time.
In conclusion, reverse engineering the brain is a multi-factor challenge requiring innovation from many different fields, both engineering and non-engineering.